Real world, things that make sound are often moving. Think of animals and insects, for example. If this is a game object, then you can just attach the sound to the object or to the object's blueprint. But with audio design, we are sometimes creating the sound of things that you don't actually see. So we need to know how to move these sounds around in space ourselves. In the meadow area of the demonstration project, that's bookmark key 3, we're going to demonstrate a reusable blueprint for movement that we've made. You can take this blueprint and use it in your own projects. We'll go through the process of how it works and how to use it. So in the Modes tab, we can search for a blueprint called Moving Sounds, drag and drop it into our viewport. We'll add a sound, in this case a sound cue called Flies, and an attenuation. This is quite a tight attenuation with a small inner radius so that we can hear the movement quite clearly. We're going to first demonstrate this blueprint actor in looping mode, so looping is checked. And so we've picked a looping sound cue. This is some flies that might be buzzing around the meadow. So randomly it will pick one of these sound files and it will loop between those. Now we're going to create a path for the sound to move along using a spline. Splines start with 2 points, the origin and the first point here. You typically leave the first one at the root of the blueprint since you'd place the blueprint where you want the sound to start from, but you can also move this wherever you like. So with the first curve point selected, we can just move that out a bit. We can hold Alt and create further curves for the sound's movement. Each curve point also has a tangent point here, which controls the curve itself. And we can also rotate the spline point. If we right click and visualize roll and scale, you can see the effect of that a bit more. So if you had, for example, a cone attenuation shape, then you could add this kind of movement to it. And from that right click menu, I'll just turn that back off for a minute. But from that right click menu, you can also choose how the line moves between each spline point. So we've just left it on the default curve. So what we'll do is add a couple of debug things to our blueprint actor. So we'll turn on a visualizer so we can see the sound's position in space, and we'll show the splines, and we'll have it automatically come on when the game begins. So you can see here it's looping, and it's going along that spline. By default, the blueprint has 2 spline components in it. So you see the second one here. So let's do something with that. And then we can randomly choose between those two. And if we open up the blueprint itself, you can also add further splines. So let's add another spline. And then with that selected in the viewport, perhaps we might change the color to make it stand out a little bit more. We compile that. And back in the editor, here we can see we've got that new spline point, which we can then use to create further movement. So let's just talk through our blueprint. So on begin play for this blueprint, we will see if the show visualizer debug option is true. If it is, we'll set the visibility of this sphere here to true. That's going to represent the position of our sound on the spline. We'll set the play rate. So this is how fast we're going to move along the spline. And then we'll take our public variable, sound, and we'll assign that to the audio component in the blueprint. We'll do the same for the attenuation settings. We'll find all the spline components within this blueprint because you may have added some more. And for each one of them, we will check this debug, shall we show the splines or not? And if that's true, then we will draw the spline in the viewport. If our blueprint is set to auto start, then we'll just carry on and we'll trigger the movement and the sound. If it's not, then we won't do anything. We'll look in a moment about how to trigger the blueprint from another blueprint. Then we'll pick a random spline from our spline array that we just made. Now this is important to note this node here, that we've given it a max value of the length of our array, but the node will return a random integer up to the max value -1. And this is important when dealing with arrays, because if we have three items in our array, in other words, the length of the array is 3, those items are stored at index 0, 1, and 2. So if we try and get a variable from index 3, there's nothing there. This is why it's important for this random integer to choose a number of length -1, and then we'll get the indexes that actually have content. In other words, index 0, 1, and 2. This section is just a bit of error checking. It may be that you've created a spline, but you haven't actually added some lengths to it in the viewport yet. So we'll just check. If it's not bigger than 150, we'll assume that it's not ready for use yet, and we'll go back and we'll choose another one. Then down here, we will play our audio component. We'll come back to this in a second. We'll play our audio component and we'll start a timeline. Now, the timeline has a float track that goes between 0 and 1, and it has an event track. The float track spline position is used to get the spline length and then multiply it between those values of 0 to 1. So those are essentially acting as like percentages of the spline length. So we're getting where we are on that spline length, and we are putting the sound in that position. And then if show visualizer is on, we're also moving the sphere to that position as well, so we can see where the sound is. Now, if our blueprint is set to be looping, when the timeline event occurs here, we're going to go back and re-trigger the whole system. So if looping equals true, we go back and trigger movement, choose a new spline, come back round again. If we are, however, using our system as a one-shot, so the looping is false, then what we'll do is we'll fade out the currently playing sound at that point. And to make the blueprint re-triggerable, we'll open up that do once so that we can re-trigger the sound and the system. The do once is there because if this audio component is a looping one, as is the case for our flies system, then what we don't want is that sound being re-triggered every time we pick a new spline. We want the audio to feel continuous even though it's moving perhaps in different directions. How we've used it so far is to auto start and to loop. So we'll just recap that. We've got 3 splines here. It starts as the game begins, and it's going to keep looping round, randomly choosing one of those 3 splines for its movement. And obviously, if we were using this in game, then we'd turn these debug options off, the visualizer and show splines. So we just have this fly moving around in space. We'll just re-enable them for the time being. Now, it may be that we want to use this blueprint to trigger a sound's movement through space, not to have it just automatically start. So we can do that. With the blueprint selected, we'll open our level blueprint, for example, and we'll create a reference to it. And if you remember, within the blueprint, we've got this trigger movement custom event. So we can drag out from this and call that custom event here. We'll just do it on a key press for the moment. Let's use Y to trigger that movement. So back in the level, that's selected. Auto is off, looping is off. So when I press Y, it should just choose one of those movements. Okay, so that's a one-off. I could trigger it again. And it randomly picked the same spline again. That's random. And again. Okay, now we've got a different one. Now it may be that I want to trigger that to start, but once it's started, I want it to continue looping. So I'm going to press Y. Now that's just going to carry on indefinitely, moving the sounds around those spline shapes. We've looked at how we can use splines to move sounds on predetermined trajectories. We've also looked at some concepts around arrays, for loops, and timelines that might be useful to you as you start to develop your own more complex systems and blueprints.